Assalamualaikum and very good day. So for today's video, we are going to learn another method on the interrupt. Previously, we worked on the RB0 interrupt for the external. So today we are going to continue the lecture for the interrupt, but for the other types of interrupt, which they call it the change on port B. It's also external. All right. So I'm going to make sure that you guys remember that this is going to be also external. Here, okay, this is external. Same goes to this one. So we are going to create an interrupt to receive an external signal and to activate the interrupt. So again, the interrupt must use the function in micro C. It must use the void interrupt over here. Then you can start to write down your coding inside the program. Right, so what is the meaning of RB4 to RB7 changes? So let's look at the okay, what's the definitions of the change on port RB4 to RB7 changes? So the interrupt change is based on these definitions, right? So change of the input signal on port B from pin 4 to pin 7 will set the RB interrupt flag, which is from the INTCON register bit. So if you can remember the last lecture, right? So we are going to look at the INTCON registers. So the purpose of INTCON registers is to set up your types of interrupt. So for the case of RB port changes, so we are going to look at that this bit number 3, okay, RBIE, which the enable bit for the RB port change interrupt enable bit. So if you set up this one as 1, you are going to use the RB port changes. All right. So if you put 0, this one say that disables the RB port change interrupt. So INTCON is the register that you have to set to choose which type of the interrupt that you want to use. In this case, we are going to learn on the RB port changes to do the interrupt. Next one, what does it mean just now? The definitions. So change of input signal on port B7 to 4 set the RB interrupt flag. So if you go back to this one, remember that when I told you guys last time, so every interrupt must have its own flag. Last week we learned about the external RB0 interrupt, right? So that is actually go to this one INTE, and the flag will be the INTF. Alright, so same goes to RB port change. So if you use this one, if interrupt happen, the flag will be set up at RBIF, which is at bit 0 here. So if you go back to INTCON just now, this is the bit. So if the interrupt happen, then the RBIF bit will be set to 1. Here is the definitions. RB port change interrupt flag bit. At least one of the RB7 to RB4 pins change state. So means that if the pin change the value from 0 to 1 or 1 to 0, in this case we are going to use this one, then a mismatch condition will continue to set the bit. So you have to read the input from this port. Okay, reading port B will end the mismatch condition and allow the bit to be cleared, must be cleared in the software. So it will always keep reading on this bit, and then you have to clear this flag again to make sure that the interrupt can be used later in the main program. So this is the normal process where you have to clear the bit RBIF to 0 back, then you can go to your main program. Okay, so that will be the difference from the last week, which is the RB0 interrupt. Actually, is quite similar. If you look at the diagram here, you can draw this diagram by using 4 switches, because we're going to learn about the RB4, RB5, RB6, and RB7 changes. And last week you learn about this one from the RB4, RB0 interrupt. So this is the one that you learned last time. to use the make a switch. So this is the what you call it, the input switch for your RB0 external interrupt. So it's nearly the same, but you have to have put extra more than one. You have 4 switches over here. You can draw and you can put you can use LED or you can use bar graph LEDs, up to you. So we're going to play around this what you call that, the simulations over here. So we are going to do this interrupt and do something here. We are going to do this interrupt, do something here, do something here, and then we're going to have this one and push this button to have the interrupt, and we're going to do something here. So in this case, right, where you can see the difference from RB0 external interrupt versus RB4CHANGE interrupt, here you have more options than one, or more than one tasks to do when in the interrupt happen. So last way is only one time, only one interrupt functions and one interrupt task that it can do. So for this case, it can have more than one to do the interrupt tasks. Alright, so here will be your input and this one will be your output. So we can go to your macro C. Again, this is the normal procedure how to write down the code. So you can start to write down the interrupt void here, void interrupt, and then you have the open bracket, curly bracket, and close bracket. So you have the min here and you have the interrupt up there. So by right, the system know if you write the interrupt over here, this is a function for interrupt. No matter what, you can use other functions to have the name with the interrupt name, because the system recognize the interrupt function as interrupt functions. Okay, then next one. Of course, the first thing that you need to do is to set up your pins, right? So here you are using, in my case example here, I'm using port D as the output, and you must use port B RB4 to RB7 as your input. Alright, so port B will be your input, port C will be your output. So we are going to write down first, try C is equivalent to 0, and tries B is equivalent to, I can put this one like this, all FF, right? Because all input, because the other pins I don't care. Then you can just run this one for you to see the build is okay, right? So there's no problem. So we can just simulate for a while for this one. So far so good, all the correct one here. Let me just clear this one, just to make sure that the port B, try C all are 0 volt for the initial value. Right. So all are 0 and the switches are ready. Right, this is all input. Now red is because of the reading from here. So if you push the button, this is correct. Okay, this is correct. And this is correct. And this is correct. So far there's no interrupt happen because you have not set up or you have not write any interrupt functions. Okay, let's go back to your coding. Okay, to set up your interrupt, so you have to change the INTCON registers. So INTCON registers 0B. So which one that you need to change? INTCON you have to set up bit number 3 only with the global one. This is a must. So 1000 1000. So this is a flag. We don't care about the flag because the flag only will be set when the interrupt happens. So you have to set 1000 1000 and semicolon. Okay, so far you have already set your pins and the interrupt. And remember that we have to use the while one loop here for your code to be infinite loop. So while one, and then open curly bracket and then close curly bracket. So you have to write down here your code. Okay, right. So let's do this. So we just try this one in the while one loop just to make sure that it's working, because we have not set up any task in interrupt. So I'm going to turn on all my port C. Port C. is equivalent to 0f 0 times ff. Okay, let's look at these results first. Okay, there's no issue at the moment. So by right, I'm expecting this one to be on all the while. So run again. Yeah, all of them are turning on because the code correctly stated that I'm turning on all my port C. Okay, so this one I don't care at the moment, so you just make sure that the port C is all 0. Just remove this one. Okay, right now how to set up your interrupt. Okay, in this case, right, because you have 4 sources of the interrupt, you have the RB4 to RB7. So there are four of them. So you must use some of the new syntax you're going to learn today to cater each of the tasks. Alright, so to cater each of the tasks. So example here, how to do that one, you can go to your help here and go for switch statement. Here, this is a switch statement. Okay, what's the function of switch statement? The switch statement is used to pass control to a specific program branch based on a certain condition. The syntax of the switch statement will be like this. So this is the statement that you can use to differentiate the task of your interrupts. So because you have 4, right? So I'm going to place one by one the case statement here. So how to do this? Alright, so what you can do is, in your program, in your interrupt here, you have to create the switch function here, switch statement here, sorry, switch. Alright, so you are going to look at which port, which is from port B. Okay, so the port B right now, okay, you are using it as all the input here. So let's look at the result here just now from your case. This is thrice B and thrice B all input, right? So means input, in this case, you might need to make the other 4 to be clearly which level that you have. So means that I want to do here is, I just want to make sure all these one are 0. So I just want to make sure that all are 0. So I just put ground here. And then I'm going to connect all the pins here to ground because this is going to be 0 all because I set up as your input. Alright. So the statement, how to do this one? Switch check port B. Okay. So the function will be like this. Open curly bracket and close curly bracket. So for the first case, right, say case 1, case 0B. Alright, so what you want to see here, maybe 1 here is going to be, this is all going to be on, and this is going to be ground. So means that if you run this one, right, for example here, you want to have all this one 1 1 1 0, like for the scale of this one. Alright, so we are going to do this one. So for the case of 0, 1 1 1 0, and the rest are all 0 because we already tied it to ground just now. Right, then what you want to do, you want to here, sorry, this is a double dot, right? This is not going to be semicolon. So you want to turn on one of the port C LED is equivalent to 0B 0 0 0 1 0 0 0 0, and then the last statement will be break. Okay, so this is the first case. If you find this one low, and then you have to turn on the bit number 4 on the LED. So we just build this one first. So right now the wall one doing nothing, right? Let's try to look at whether it's correct or not. While 1 is doing this one, is it going up here or not? Let's check the results here. So right now we are going to turn off this one, right, the first one. So you can see the result is actually turned on because of the interrupt happen, and you are going to have the results over here, this one. So you can compare, you can copy this one again for the other case. copy, copy. So change this one, the changes for the other pins. So this one should be 0, and this one should be 1. This one should be 0 here. This one should be 1, and this one should be 0. So the case will be different like this. So this one may be 1, 0. You are going to turn on the LED differently. Right, so means that right now, if you push the button here for 0, then you have this one, bit number 5 to be turned on the LED. So when you push the button for this one, then you are going to turn on this one, and then you are going to push the button here, this one, and you have the break here. Okay, so now you have the 4 conditions. Alright, so while one here doing nothing because this is the initial value for your port C. So you are expecting it to go up there and checking the changes, right? Alright. Now let's look at the result, whether it's still correct or not. Okay, now run back this one. And then I push this button, it's working. Push this button, it's also working because there are changes. Alright, there are changes happens because it's keep on reading. When something happen, it will change. It will change. Something happened. That's why in the definition just now, change of input signal, set the RB0, right? So for this case, right, you must check, you must understand that the changes, because my switch is changing. The value, the results here is 5 to 0. This is also 5 to 0. So this is the case. So just to make sure that if you need to have another interrupt to happen, right? So you must make sure that the flag should be cleared over here because it will wait. So let's say, for example, here, right now, in your code, you must clear, after this case, you must clear your intf.rbif must be cleared by software. This is a command, cleared by software, the flag for the interrupt. The software must clear it because it's just want to make sure for the next interrupt to be happen. So here you can just build this one. Oh, so this is, sorry, INTF. Sorry, this is not INTF, this is INTCON. Alright, so build. This is the register and the bits of the inside this register. So build this one, and then you can do the changes here on your Proteus. I already have it done by default. So now you can see the result is correct. So let's say that if you put the main program inside there, right here, as port is being to be port C is equivalent to 0, means that once the interrupt happen, it will go here, right? So if the interrupt happen, it should go and clear the port C. Let's look at the result, whether it's correct or not. So the changes happens very quick, so it will not, you cannot see it blink, and you just make sure that if you want to blink it, you must delay the interrupt. Let's try to delay the interrupt. So in the interrupt, you are going to delay ms 1000, right? Build. See, 1 second. Now the reading does not changes, right? Because the reading is always like there's no mismatch. So I'm going here, 1 second is turned off because it go back to your main functions here. It will turn off, and once the interrupt happen, it will go up, and then once finish this one, it will go down back. This one is going to do the infinite loop. So that's all for the RB port changes on the interrupt. Means that you can see the difference on the external RB0 interrupt versus this one. Thank you very much.